Okay, so this is my presentation on visual spectroscopy by Ruben Boswell. My introduction is UV visual spectroscopy is a technique that readily allows one to determine the concentrations of different substances and therefore enables scientists to study the rates of reactions and determine the rate equations for a reaction from which a mechanism can be proposed. I also capture a graph from the spectrometer on the different concentrations of the inks I've used. Okay, this is my method, and on the top left we've got the spectrometer, and the bottom left we've got the cuvette, where you put the cordials in or inks in. So the computer is ready set up for you already. So all you need to do first is press collect, and the instrument will start to warm up. When the instrument finishes warming up, it will just say and you press finish calibration. You must get to cuvette, fill it 3/4 with water, and then put it into the spectrometer. And then you press finish calibration again. After after you have chosen your first food coloring to add to the cuvette should be 3/4 full, which is key. Place the cuvette in the spectrometer and then press collect. Following this, press stop and look for the maximum absorption and record the wavelength. You can also do this by touching the peak on the screen and reading the value in the lower left corner. Now you are going to measure the absorbance of different unknown cordial solutions. First, you need to make up solutions of the different percent concentrations or dilutions. So to do this, you need to make up 3 solutions in each of the test tubes and then put them in the cuvette 3/4 full. The amount of the cordial should go up and the amount of water should go down as you're adding more. Fill the 6th cuvette with undiluted cordial and then measure the absorbance peaks, concentrations, and record the value of the maximum absorption on the data sheet. Of the concentration absorption of the unknown solution 3 times. So you want to do that 3 times. You can now get the concentration, the absorption concentrations from the unknown solutions by just comparing the absorbance to the absorption concentrations. I don't know if that makes sense or not. See, these are my results. You can see that's the graph on my left. This is my graph me and my partner diced it. And here it is. And then on the right, we got the absorption peaks from the different inks. You can see red, orange, yellow. And my line and cordial, you can see as a percentage go up. Or you can see, and the unknowns A, B, and C. And my conclusion is I thought this experiment was not that interesting to me because the only skills you had to learn was measuring 3/4 full of water and cordial in the cuvette. And putting this cuvette in the spectrometer and reading the graph, that's it, honestly. The most interesting thing was interpreting the graph and writing results from the graph. It is more like a physics experiment than a chemistry experiment, to be honest, in my opinion. The yellow cordial had a highest concentration peak or absorption peak of 1.214, and purple had the lowest absorption peak of 0.591. The purple cordial had the lowest absorption peak, and probably because purple light has the lowest wavelength and highest frequency. For the lime cordial at 20% had a concentration absorption of 0.635. And for the 80%, it had a concentration absorption of 0.538, and this shows a decrease in concentration absorption. And then lastly, the unknown ones, A, B, and C, had concentrations of 0.114, 0.098, and 0.097. and which is again shows a decrease in concentration. And then lastly, just my references here. You can see what is visible, spectroscopy, my cuvette picture, my spectrometer picture, and that's it.